Right. Although I work in non-session, I do try and get down here a few times, although you probably haven't noticed me very much, but I have been to a few of the previous seminars here. What I want to just run through here is the development of the LiceBoss decision support systems, why we started with a lice population model and switched to a damage development model, and what was the calculations were going on there, how we use Boolean networks sorry, that's Bayesian networks for probabilities, just some decision trees in other models, and some of the lessons we've learned from modelling along the way. Now, I need to give you just a little bit of background about lice in sheep. It's not a big animal welfare issue in the sense that these lice live on the wool of the sheep. They run up and down the fibre of the sheep and live on the skin, but they don't actually bite the sheep. They're not biting lice, and so they irritate the sheep by making it itchy. But that's the main effect on the sheep. But the problem is this: because the sheep is feeling itchy, it rubs on things. So it rubs on fences, trees, posts, anything it can find. It bites at the fleece, so the sheep do the biting and rubbing themselves, and this causes wool damage and lowers the fleece weight, so there can be a dramatic drop in the weight of the fleece. The fleece gets dirty, and all the rubbing causes clotted wool, which dramatically lowers the value of the fleece. But there's not actually a change in the body weight of the sheep, so the sheep themselves are not actually getting sick from the lice. It's a loss of wool, which is the main problem that we're concerned about here. The sort of loss we're talking about, you can lose up to 30–35% of the value of the fleece on animals that are seriously affected, and in a whole flock you can lose 5 or 10% of the fleece weight if the infestation is not treated. In order to avoid these sort of losses, there's a large amount of pesticide use on sheep, because the only way to control lice is with putting pesticide on the sheep, and preferably covering the entire sheep with a pesticide. So there is a problem with the amount of pesticide that's needed, and that is a significant part of the cost. So it's costing altogether, allowing for the chemical use and the wool loss, it costs Tasmania about $3 million a year, and about $70 million for the whole of Australia. And then there are some the not direct dollar losses related to the use of pesticide that we're also concerned about. If you're looking for lice on sheep, you normally do it by parting the wool like this and looking for the lice close to the skin. These pictures of lice are magnified. The lice are actually only about 2 millimetres long, so they're actually quite hard to see. However, when you part the wool, you can see them quite easily, provided somebody draws a nice orange circle around the thing. There's a louse up there. However, note that this is somebody's thumb here, so you can see how magnified it is, and you can appreciate the difficulty of actually finding lice easily when you're just looking at sheep normally. Just a quick run through of a few points you need to know about the life cycle to understand what we were doing with our modelling here. The female louse lays only 1 or 2 eggs every 3 days, which is actually a fairly low reproduction rate for an insect pest, and it means lice build up very slowly, so that by the time you actually know you've got a lice problem in the sheep, the lice have probably been there for months, possibly 6 months or more. So it's very difficult to actually track the source of the lice and see where they came from. The eggs are laid on the wool, the egg hatches, and then the nymph molts 3 times. And the point here is that the entire life cycle is spent on the sheep. These, unlike a lot of other insect pests and internal parasites, they don't have any part of their life cycle off the sheep. They can survive for a short time off the sheep under appropriate conditions, but they cannot reproduce off the sheep, and that means that an important part of treatment is simply killing the lice while they're on the sheep, and if you do that, you've got rid of the lice. Another point you'll notice in the pictures and the little diagram here, these lice don't have wings. If they want to go anywhere, they've got to walk. So the only way lice can get from one sheep to another is by actually walking across. They move out to the tip of the wool, walk onto the sheep standing next to it and transfer that way, so that lice not only reproduce fairly slowly, they also spread through the flock fairly slowly. But this does make a number of control issues much easier for us. So the important things we need to remember is that if you can kill all the lice on the sheep on the property, then you've got rid of all the lice there. They're not going to come back unless lice come in from some other way. But it means you've got to treat every single sheep correctly, and this is where a lot of problems arise. That if a single sheep is not treated correctly and all the others are treated and eradicated, that sheep can maintain lice in the flock. And so correct treatment and treatment of every sheep is a critical part of the system. But nevertheless, if there are no lice on the sheep on the property, then there's no point in doing treatment. And we know that only at any given time, about 20%, possibly up to 30% of flocks have any lice in them, of properties with lice on, but about 60% of properties treat for lice every year, which indicates that there's a lot of treatments being used that are not actually necessary, and we'd like to try and reduce the unnecessary use of pesticide and the extra cost involved. And as I mentioned before, they only transfer. There are some rare cases where you might get physical transfer of lice, but generally it's by sheep standing right next to another sheep, and the lice moving across is the way that they transfer around the place. Now, the LiceBoss project is primarily a website, although there's also a LiceBoss CD. The LiceBoss website has a whole lot of information about control of lice, and I won't be considering that. The area I was involved with the information section, but the area I was most concerned with the LiceBoss decision support systems, which I want to talk about today. We started off this project with the aim of looking at long wool treatment of lice. Now, long wool treatment in terms of lice is a bit misleading. Long wool means anything more than 6 weeks wool. And the reason for that is that if you're trying to eradicate the lice, if there's more than 6 weeks after shearing, then the wool is too long to completely cover the sheep with chemical or pesticide to kill all the lice. So any treatment after more than 6 weeks will only control the lice, it won't eradicate them. And so that's the difference between a short wool and a long wool treatment for our purposes. And that means that if you use a long wool treatment, you're still going to have to treat it the next shearing. All you're going to do is control the lice. And so a lot of treatments like this are unnecessary. They invariably cause high issues with pesticide residues in the wool. And so what we wanted was to have a decision support system for lice in long wool to decide whether you should actually treat immediately, and with the assumption that you will then treat again after shearing, or whether you're simply better not to treat until shearing, because this depends on how rapidly the wool damage is going to occur. And a possibility that tends to come up, and I'll discuss later, is treating just the sheep that appear to be affected, and then obviously treating the whole lot after shearing. Now, we did a user needs analysis here to see what people really wanted, and they said yes, they definitely did need this long wool decision support system, but they're also desperate for better information about the products they use, because as I said, all treatment involves some sort of pesticide, and each of them has different problems, issues with hold periods and so on. But they also said they'd like a decision support system for treatment immediately after shearing, because as I said earlier, about half the treatments after shearing are not actually necessary. and so they needed better information about whether they needed to treat or not at that point. Now, our initial idea for the long wool model was that we would get some estimate of the lice at the moment. We have population models for lice increasing on the sheep, so that wasn't a problem, and then we'd work out the damage due to the lice. Sorry, I went the wrong way then. Try again. Got it. Now, there's a problem in estimating, in this first step of estimating the number of lice now. Because the distribution of lice on the sheep is not even. There will be a small, most sheep we'll have a fairly light infestation. So this is the number of sheep in the group, and this is the number of lice per sheep. So most of them are going to have a small number of lice on them. But there'll be a small number which will have a very heavy infestation. And that means sampling your flock and getting an actual, a genuine estimate of the average population of lice on the whole flock is quite difficult. Because it depends a lot on how many of these came into your sample, and if you only do those, then you'll obviously get some sort of bias. So we need some other method of estimating the number of lice, and so and counting lice is actually extremely labour intensive. As I showed you from that picture earlier of trying to find them. So what we decided to look is what proportion of the flock were affected by lice with visible signs of rubbing on them. And what happens here, I've again got this lice population group, but this time I've got a log scale. So this is a log scale down here, and we get a normal distribution of lice when we do it on a log scale. And what we find is that if the number of lice is more than about 500, then the sheep will show visible signs of rubbing on things. If the number is less than 500, then normally the sheep are not irritated enough to show any signs of rubbing. So that means if we get an estimate of the proportion of the flock that's in this category out here, we know from a lot of other studies what the standard deviation of this curve is on the log scale, and it's then trivial to estimate what the average lice population is from the area under this part of the curve here. So that meant it was fairly easy to transfer from the proportion of the flock affected to the number of lice in the flock. We can then get the population increase of lice. Again, this is a log scale here, and initially it tends to be linear on a log scale, but then flattens off as the lice population increases, but that's fairly easy to calculate. And then the final step, we need to convert the number of lice to wool damage. But the damage depends on how long the sheep have been infested with lice, not just on the number of lice they have at the moment. So we realised we needed to use lice-days, where for each day we estimate how many lice on the sheep. So if we have this sort of increasing, this is the number of days the sheep are infested, and this is the top of the curve is the number of lice on the sheep, and the area under the curve is our lice-days. So we can estimate all that easily enough, and then there were quite a large number of published studies on the amount of damage from lice, from which they didn't actually report lice days in their papers, of course, because they weren't thinking along those lines, but we were able to calculate the number of lice days from those studies. And the blue dots on here indicate a published study of the percent loss of wool in that study and the lice days, and the red dotted line here is the line of best fit through those points. Now, some people looked at this and they thought that's not a very good line of best fit, but I convinced them that the line had to go that way. I won't try and convince you, because in fact when we thought about publishing this, we thought there's no way we were going to publish a graph like that, and so we thought maybe we need to do this another way. Now, what we've been trying to do was measure the amount of, get an estimate of the amount of sheep, proportion of the sheep rubbing, convert that to the number of lice on the sheep, use the population model to get lice increase, calculate lice damage and lice days, and then calculate damage. And we thought, why don't we simplify this? We need to measure the amount of sheep of the rubbing. Why don't we just measure the amount of the increase in the rate of rubbing of these sheep, because that's really what leads to the damage. So technically it's not the lice themselves that are damaging the wool, it's the rubbing that's doing it. So we decided to try simplifying the model to run it through that way, and just skip, although it would have been nice to use the lice population model, but it wasn't giving very good damage results on our damage calculation. So just to check whether we can do that, the scientists who do all these things on lice get an average rub score, which can go from 0 up to about 5, and and measuring the type of wool damage that's found on these sheep. We don't expect the farmers who are supposed to be using this decision support to be able to use the same scoring system. All they need to do is say how many sheep are showing signs of wool damage. And so and this is the percent of the flock that are showing visible signs of wool damage that a farmer will be able to recognise. So if they say 20% of the flock is affected, we can work out that the average rub score of that flock is 0.8. If about 60% are affected, then the average rub score is 2, and so on. So that it's quite a good relationship here between the proportion of the flock that are showing any damage at all and the average rub score for that flock. And then we found that this time the average rub score is up here, and this is time over here, and you've got essentially a straight line here as the rub score is increasing. The average rub score for the whole flock is increasing at a linear rate over time, so that was very nice. And finally we come to the area that caused the trouble earlier. These were from experiments that were being done using this rub score system. So this is the average rub score here, and this is the percent loss due to wool. And you can see again the red dots are my fitted line, and it's now a much better relationship with the actual data points that we used in these experiments. So this appeared to be a reasonably satisfactory model, and much better using rub directly and the rub score than trying to go through the population model. Now, the sort of results we get after we use this type of model, if supposing we've got a flock of sheep and there's a certain proportion of the flock showing signs of wool damage, if you look at just this blue line initially, this is what happens if we don't do any treatment for the sheep. This is how long we're going to wait until we shear these sheep. This is the dollars we're going to lose on these sheep. And you can see that the longer we wait, the worse the situation gets, as the wool damage increases more or less exponentially for quite a while before it flattens off, so that the wool damage will increase to very high levels if we do nothing, but it does take a while before it starts to increase. The alternative is that we actually go ahead and treat all these sheep. And if we do that, we're up for an upfront cost, because it costs quite a lot to treat every single sheep in that group. But once we've done that, then there's no further wool damage, at least for a while. As I said earlier, you never actually kill all the sheep, all the lice, sorry, on end of the long wool treatment. So after a while, that curve will start to go off a bit, but it takes a while to do that. Now you can see that in this particular situation I've got here, if you've got less than 4 months to the next shearing, then on an economic basis you actually might as well just let the sheep go, don't treat them, and you'll get some wool damage, but it will be less than it would have cost you for the treatment of the sheep. Clearly, if there's more than 4 months to go to shearing, then you're much better off to go and treat them right away and keep that damage to reasonable levels. Now, this curve does not always stay in that position, because it depends a lot on the initial wool damage. There will be cases where you've already got quite severely affected sheep where it will shoot up quite rapidly, and other cases with a very light infestation where it will only increase slowly. So that this is where the decision support's needed to estimate what the position is at the moment, and then how rapidly that is going to change compared with the other option of treating all the sheep. And I did mention earlier the option of only treating the affected sheep, which a lot of people want to do. And in that case, supposing initially about 20% of the flock are showing some signs of rubbing, you'll have an upfront cost of treating those sheep. But the other sheep which you haven't treated will still have lice on them. They've just got a lower level of lice. And so wool damage will increase in those other sheep, but at a slower rate than in your completely untreated flock. So you get this red line that comes up here, and it may come under here, which would indicate that for this sort of period you're better off only treating the affected sheep. And this is one of the big problems of lice control, and it's a problem because it's always raised at workshops and we're not really quite sure yet how to answer it. Do you get this sort of situation where you have quite a long period where you would have been better off to only treat the affected sheep, or you get that sort of situation where in fact you're never better off only treating the affected ones. You're always better off going one way or the other. And one of the things we're planning to work on at the moment is to try and answer this, to see, are there any situations where this occurs, or in all the situations people likely to find, are you likely to get this situation? Because clearly there's a significant saving at certain stages if you only need to treat the affected sheep. Now, there was a problem with this Wool Decision Support System, and that is that we've assumed that if the sheep are showing signs of rubbing, we can use that, the proportion of the flock that are rubbing, to start off our estimate of the lice damage and the increase that might occur. Now, there are actually some other causes that will make sheep rub for, or appear to be rubbing, causing wool damage for various reasons. So we really did need to help people decide whether lice really were the cause of rubbing. And I'll just leave that because we're going to come back to it for another reason later on. I'll now go to the short wool decision support system that I said our users wanted. Basically what we're trying to do is say that this is for use at shearing or immediately after shearing. Are there any lice on the flock? If no, there aren't, then you don't treat. If yes, there's lice there, then you should treat. So that sounds nice and simple, except that it's not easy to work out whether there's any lice on the sheep or not, because just trying to do it by parting the wool you will you'll often not find lice even if they're present. So we needed some means of estimating whether lice were likely to be there. And there are three reasons why you might have lice in your sheep at your current shearing. One is that you had them 12 months ago at your previous shearing and you treated them but you failed to eradicate. So they might be leftover lice from 12 months ago. Or you might have bought animals and these brought lice in with them. Or they might have come in as strays. Now, every producer always blames strays, but in fact our studies have shown that they're just as likely to have come in on animals you've deliberately brought in yourself as they are to have come in on stray sheep. And a lot of current infestations are simply there because you failed to treat adequate last time. So we needed, basically these three are about equally important in terms of deciding whether you have lice or not. So we needed to ask suitable questions about each one, and then we're not going to be able to come up with an absolute yes or no answer. We're not going to be able to say, no, you definitely don't have lice. We may be able to come up saying, yes, you definitely do, if you actually find lice there. But what we're looking at are probabilities here, of that. What's the probability that you have lice? And Bayesian networks are ideal for doing these probability calculations. And for those who haven't done a lot on Bayesian networks yet, they're fairly straightforward. And I'm going to run through the classic Bayesian. You're just going to get the 2-minute version here of how to do a Bayesian network. Let's suppose you go out to get the paper in the morning and you walk across the lawn and the grass is wet and you say, oh, it must have rained overnight. Well, it might not have rained overnight because you've got sprinklers on your lawn and the sprinklers might have gone on overnight and caused the grass to be wet. So that and in this little scenario we're trying to estimate what was the chance that it rained overnight. So you need to know what was the chance the sprinklers went on. And this will depend on the season, because it's much more likely your time system's set up so it's much more likely the sprinklers will go in summer than in winter, and it's a bit more likely it'll rain in winter than summer, although clearly it can at any time of the year. But if we actually know the probabilities that your sprinklers go on in different seasons and the probability that it rains in different seasons, and if these events happen, whether they'll actually wet the grass enough for you to notice, then from your knowledge of whether the grass is wet or not, you can get an estimate of whether it rained overnight. Now, you might think this is a silly way of working out if it rains, but the point is this is a nice simple example that you can actually see what's happening, and as I said, it seemed to be a classic system that whenever you look up how to do Bayesian networks, they'll run through this little sort of calculation. What we'll do is look at the real ones we had with lice. What we're trying to find out in one of those three scenarios, I said you failed to treat after shearing, and so what we want to know is whether you actually have lice after shearing. Is this true or false here? And this, for that you need to know whether you thought you had lice last year, what treatment you actually used, and what's the chance of success of that particular treatment. And in the initial run, what we did was use published values which said on average about 65% of the time when you treat for lice you can eradicate them, the other 35% you don't. So we popped that number initially, but I'll come back to that one later because we had to work on that a bit more. The split shearings mean if you're not actually shearing and treating all your lice at the same time, there's a chance from lice to transfer from untreated back to treated ones, and that reduces the chance you eradicate. So those sort of questions looked at whether you eradicated last time. We had to look at whether you actually deliberately brought in animals that had lice on them, so we consider whether you actually introduced any sheep, do you know anything about the people you were buying them from, whether they're likely to have lice or not, and then if you did get sheep in, you might or might not have quarantined them for a while, long enough for lice to show up. You might have actually inspected them to see if they have lice, or you might have treated those sheep. And an interesting thing is that when we run these sort of things at workshops, people realise that in fact they tend not to do any of those things, and that they are in fact taking risks, and this is why they tend to have lice on a regular basis. So one of the values of our decision support system was actually making people think of some of these things that they could or should be doing. In the case of lice coming in on strays, it depends whether you know anything about your neighbour, whether they have lice or not, whether you actually saw strays during the last year. If you didn't see strays, then are your fences good enough that you're confident that they wouldn't have been there? Because if they're bad enough, the sheep might have wandered in and then mixed with your sheep and then wandered out again. Now, having done those three separate sections, we put them together. So those three boxes at the top actually have trees or networks leading down to them to give you the probability where the lice might be there at the moment. If you have lice, then you may get some signs of rubbing. You don't always get rubbing even if you have lice there, because there are some, either the lice might have come in very recently, or you might have used a chemical on your sheep which controls the lice without actually killing them all, but controls them enough that they're not causing signs of rubbing. So this isn't a definitive trigger for lice, and also there are some other causes of rubbing. Nevertheless, the rubbing is a good indicator of whether you might have lice or not. So we set up this tree, and this, as I said, you've got other bits feeding into the top ones there. There were two major problems with it. One was that it was far too dependent on this rubbing. Basically, this was tending to drive the whole model, so that the model more or less said, if you can't see any signs of rubbing, you probably don't have lice, so don't treat. If there is any rubbing, you can't take the risk, you must treat. And so it had become a question of are the sheep rubbing or not, or showing signs of wool damage. The model was also, in other respects too, dependent on this 65% figure, which we did allow the user to change, of the chance of the treatment being successful, and there was too much on what was effectively an average figure, but which could vary a lot from person to person. So we needed some more rigorous method of estimating the treatment. We'll go back to the rubbing one. We need to use this rubbing model because the long wool model really needs to know for sure that it's lice that are causing the problem, and we need it to evaluate the short wool model correctly to get much better estimates. And it also does help people in terms of telling them what other causes of rubbing they might have. Now, I had this decision tree given to us on paper, which you can't read, so I'll zoom in the top bit. And this decision tree is fine, except that it has there's a couple of defects in it, but a problem is that you only end up at one point on a decision tree. You work your way through the tree, and at some point you'll pop out to an answer. Now, the problem is you can actually have more than one answer valid. For example, grass seeds might be causing a problem with your lice and making them itchy and rubbing, but obviously they don't protect against lice, so you could have both lice and grass seeds or itch mite or whatever. So that what we need to do is to work on this decision tree a bit, and basically we turned it into another Bayesian network, so that we had all the possible reasons why sheep might be rubbing and the various questions to help identify those causes, all leading down to whether they're rubbing or not, of which lice was one of them. And so we can now estimate whether you might have lice and whether some other problem is causing the rubbing. For the treatment decision support, although we had this estimate of about 65% success, we also did have a lot of good data on the things that can go wrong with lice treatments and what issues they occurs and what sort of probability of failure they might have. So that again, with the treatment, we needed to do this because there's a whole three basic methods of treatment. There's the plunge dipping, and clearly there are certain procedures about the plunge dipping which are only related to plunge dipping. So if people are plunge dipping, we only ask questions relating to that. If they're shower dipping, it tends to be mechanical problems about the sprays and things that cause trouble, although there are also things relating to making up the dip mixture. Then the other treatment is a long wool backline, short wool shears backline treatment, where you drip the chemical down the back of the sheep and hope that it's going to spread around it. And there's other quite different problems there. So the idea was to ask questions that were appropriate. Some questions do apply to all treatments, like do you actually round up every single sheep on the place and treat them? Others are specific to the method, and a few are specific to the type of chemical that's used. So we had another, I'm not showing you that one, but we had another Bayesian network for treatments, and that fixed our problem with the short wool model to that it uses rubbing correctly to come to an appropriate decision, and it estimates the effect of treatment correctly. Now, I mentioned with our user needs analysis early on that people wanted a products list and a wool residue calculator to estimate the pesticide residue for the treatments. I won't run through those. The other one that came up, which we weren't asked for initially, but tends to come up any time you talk to producers about lice control, and that is the problem of ewes and lambs, because quite a lot of treatments don't kill all the lice immediately. They might kill them eventually, but not right away. So that if ewes are treated shortly before lambing, then there can still be live lice on the sheep when the ewes lamb. They transfer to the lambs, all the lice on the ewes die off, but 3 months later the lamb's still running around there and transferring live lice back to the ewes. So that transfers between ewes and lambs are a serious problem. And in that case we did use a decision tree because we found basically there were a set of questions you could ask, and you end up, the bottom bits down here are points where, okay, if you've got to that point, these are appropriate treatments to use on the ewe and the lamb. So we didn't get fancy on that one, we just used a simple tree structure. So although we'd started off only planning to write a long wool decision support, we actually ended up with all these different models in the system by the time we'd finished. I do work on quite a lot of other models. They mostly related to lice and fly strike, although I do branch out into other areas at times. But I won't try and run through the others today. This is my last effective slide here. There are a few things we learned from doing this sort of thing. One is that sometimes a simple model is better, as we found. Instead of our complicated lice population model, we just simplified it to a little rubbing model, and it gave a much more robust result. But sometimes you do need to complicate things up a bit, as we found with the short wool model, where we tried to simplify things with the rubbing and treatment, covering them with a single question, and we ended up having to ask a whole series of questions to cover those situations, because otherwise the model simply wouldn't have been satisfactory. The user feedback in the early stages is really important. We would have been in real trouble if we'd done all the development that we were planning to do, and then at the end of the project we go to some users and say, okay, what do you think of it? And they say, well, it doesn't do this and this and this. but we would have run out of time then, whereas we did our user feedback in the very early stages. And the final message is that when you work with models, you almost invariably end up doing more than you originally planned to do. And that's about the end of it.